Good morning, students. In this session, we are going to discuss about desalination process, that is reverse osmosis. Learning outcome. At the end of this session, student will be able to acquire basic knowledge on osmosis and reverse osmosis. In the meantime, you will gain some knowledge related with the SPM, that is semi-permeable membrane, and osmotic pressure, its advantages and disadvantages. What is desalination process? It's from the term itself, it's clear removal of salt content. A process that removes dissolved minerals from seawater, brackish water, and wastewater. Here we highlighted some of the salt content range. That is, for washing water it is 35,000 ppm, for brackish water it is 1000 to 10,000 ppm, and for fresh water it is less than 1000 ppm. 300 million people worldwide rely on desalination for their freshwater needs. Before getting into the topic of reverse osmosis, to do it better, you should know some basic concepts related with osmosis. What is osmosis? The process in which solute is dissolved in a solvent and the solvent moves through a SPM into a solution of higher solute concentration. The concentration of solute on the two sides of the membrane tends to equalize. And to understand the normal osmosis, I think it's better to have a clear idea regarding diffusion. Diffusion simply says molecule spreads from area of higher concentration to an area of lower concentration. A simple examples may help. If you're boiling a tasty soup in the kitchen, those delicious molecules don't just stay concentrated in the pot. They gradually move throughout the house, filling the area with the wonderful smell of cooking. In other words, they diffuse from the area of higher concentration, that is from the pot of the soup, to lower concentration, the rest of the house. Osmosis is a special case of diffusion in which all molecules in water and the water crosses a barrier of semi-permeable membrane, and this semi-permeable membrane allows water to pass right through it. Okay. What is osmotic pressure? The pressure that must be applied to a solution to prevent the flow of water across the semi-permeable membrane. Here we'll show in a diagrammatic aspect. Here we are applying the pressure, and the notation of pressure is this one. And the formula for calculating the osmotic pressure is nothing but MRT. Here that M indicates the molar concentration dissolved in the system, and R is nothing but initial gas constant, and T is the temperature in Kelvin. Let us have a small problem solving related to the osmotic pressure. Given that the average molarity of seawater is 0.479 and a temperature of 293 Kelvin, calculate the osmotic pressure. Here, the information provided are concentration of the water, that is 0.479, and temperature. The equation is pi equal to MRT. The M value is 0.479, T value is 293, and R is nothing but dissolved gas constant. Let us apply all these values in the formulas. And finally, it ends up with the osmotic pressure of 11.52 atm. Now let us enter into the topic of reverse osmosis. What is reverse osmosis? And unsurprisingly, reverse osmosis is the opposite of osmosis. The solvent water filters out of a high concentrated solution into a low concentrated solution. Pressure must be applied to a salt water side of the tank to push the water through the membrane. Here we highlighted a diagram for your understanding purpose. The left hand side is the salt water and the right hand side is the fresh water, yet separated by a SPM. Therefore, the reverse osmosis makes desalination process easier, than almost 60% of desalinated water was treated by RO in 2008. Now the question is, how much pressure must be applied in a RO? Pressure is equal to force by area. Must apply enough pressure on the saltwater side to the tank to encounter the natural osmotic pressure as well as enough pressure to push the water through the filter. 32 to 50 psi for fresh and brackish water, 600 to 1000 psi for seawater, 350 psi of natural osmotic pressure. Here we listed out some of the history of the reverse osmosis development. In 1950s, researchers began to look for ways that ocean water could be desalinated. In next 1959, researchers at Berkeley created a functional synthetic RO membrane from cellulose-acetate polymer. It could reject salt and pass freshwater realistic flow rate and pressure. In 1965, the first RO desalinator plant in Carlinga was developed. Here I highlighted some of the link for the video clips of reverse osmosis functioning. And this is the today RO what we are using in our day-to-day life. Where is reverse osmosis most frequently used? The Middle East. It receives only 20 to 40 centimeters of water per day. Oil rich, which keeps energy prices low. 70% of Saudi Arabia water comes from desalination, but only 50% of the amount used are RO. Disadvantages. Disposal of brine, the wastewater from the RO process that was having a high salt concentration, generally twice as much the intake water. Brine is disposed back into the ocean. Long-term effects on marine life are not understood. It can mix with back into the open sea water with a high-speed jet, so salinity level are back to the normal within 100 feet of the release point. Inefficiency of the RO process. 55 to 70% of intake water is discharged as brine. Let us have a few discussions related with reverse osmosis performance and design calculations. Okay, in order to accurately measure the performance of RO system, you need some basic parameters. Should know the basic knowledge of parameters such as feed pressure, permeate pressure, concentrate pressure, feed conductivity, permeate conductivity, feed flow, permeate flow, temperature. I think it's better to understand all these terms to design a RO system. Okay. What maintenance is performed on a RO plant? Preventive maintenance. What is preventive maintenance? Instrument calibration, pump adjustment, chemical feed inspection, and adjustment, leak detection and repair, and structural system repairs. Falling. Caused when membrane pores are clogged by salt or other particulates. Membranes must be cleaned or backwashed about every 4 months. Cartridge filter elements must be replaced about every 8 weeks. The membrane lifespan is about 2 to 3 years. And again, the lifespan of the membrane that depends upon the nature of salt content and the quantity. Could a RO desalination be powered by renewable energy? Yes. Since the largest obstacle for RO desalination is high energy needs, could this be avoided by using renewable energy? Number one. A RO desalination is designed to be powered by wind or solar energy. Here is a question. What is the application of RO in the various disciplines in industries? A reverse osmosis system is built around its individual membrane. Each membrane is a spiral wound sheet of semi-permeable material, and the membranes are available in 2-inch, 4-inch and 5-inch diameter, with the 4 and 8-inch diameter size most commonly used in industry. And the industry has accepted a 40-inch length as a standard size, so the membranes from different manufacturers are interchangeable in equipment systems. One of the primary measurements of membrane is its square footage. Membranes are available in the range of 350 to 450 square feet of surface area. Semi-permeable membrane was first constructed using cellulose acetate, as already we discussed, but later the industry switched primarily to the use of thin film composites. It is the latest technology in the industries, being placed on top of sound substrate. TFC's membranes are primarily used today. And what are the other related information should know before doing the desalination process. As we stated earlier, we should know the understanding the difference between passes and stages in reverse osmosis and single pass and double pass reverse osmosis that depends upon the nature of water to be purified and the nature of contaminants. Normally, what type of contaminants can be eliminated through reverse osmosis process? It is capable of removing up to 90% of dissolved salts, particularly salt content ions, particles, colloids, organics, bacteria, pathogens from the feed water. An RO membrane rejects contaminants based on their size and charge. Any contaminant that has a molecule greater than 200 is likely rejected by a properly running RO system. Likewise, the greater the ion charge of the contaminant, more likely it will be unable to pass through the RO membrane. For example, a sodium ion has only one charge, that is monovalent, and is not rejected by RO membrane, as well as calcium, for example, which has two charges. Likewise, this is why an RO system does not remove gases such as carbon dioxide very well, because they are not highly ionized while in solution and have a very low molecular weight. Because an RO system does not remove gases, the permeate water can have slightly lower than normal pH depending on carbon dioxide level in the feed water, as the carbon dioxide is converted to a carbonic acid. Reverse osmosis is very effective in treating brackish surface and groundwater for both large and small flows applications. Some examples of industry that use RO water includes pharmaceutical, boiler feed water, food and beverage, metal finishing, and semiconductor manufacturing and so on. And here we provided some group activity. This is a new technology that could improve RO desalination or desalination in general and present findings. And the technology could be one that improves efficiency or decrease negative environmental impacts. And here we highlighted some of the link for the development of the latest technology in RO. And it's better to think in a way of designing a semi-permeable membrane aspect so that the efficiency of RO can be increased. And that's all about the reverse osmosis process. Thank you for your cooperation. Happy learning.